Description of the binary table representing odd numbers. The table consists of a vertical axis named k, which represents the index of an odd number. The odd number ni is represented by the vertical axis ni. The odd number ni is written as being equal to twice the value of k plus 3. The table consists also of an horizontal axis named j, representing the index of an odd number. This odd number is a factor that allows decomposing odd numbers. For example, the odd number 15 is decomposed into two factors, 3 and 5, since 15 is equal to 3 times 5. The value of the factor is written as equal to twice the value of j plus 3. We will show how to complete each cell of the table with a binary value equal to either 0 or 1. The value of each factor is written in binary mode with an increasing number of binary values. We will see that this number is equal to the value of the factor. Factor 3 is written with three binary values 0, 1, 1. The first odd number created with this factor is obtained for a value of k equals to 0. That is to say, for an odd number equals to 3. The odd number 3 is equal to 3 times 1. It decomposes with only the factor 3. The odd number 3 is equal to the factor 3. It is a prime number. The second odd number created from the factor 3 is obtained from the value of k equals to 3. That is using twice the factor 3, and therefore, in binary mode, it is written as 0, 1, 1, 0, 1, 1. This corresponds to an odd number 9 equal to 3 times 3. Odd numbers which are multiple of the odd number 3 are created by adding to each new value the binary value 0, 1, 1. Factor 5 is written with 5 binary value 0, 0, 1, 1, 0. A binary value 0 is added to the beginning and to the end of the binary series representing the value 3. The first odd number created with the factor 5 is obtained for a value of k equal to 1. That is to say, for an odd number equal to 5. In the binary series 0, 0, 1, 1, 0. The value 5 is obtained by the second binary value 1. This odd number 5 is decomposed with only the factor 5. It is therefore equal to the factor 5. This factor is a prime number. The second odd number created from factor 5 is obtained for the value of k equal to 6. That is to say, using twice the factor 5. Therefore, in binary mode, it is written as 0, 0, 1, 1, 0, 0, 0, 1, 1, 0. This corresponds to an odd number 15 equal to the product of the factors common to k equal to 6, that is to say 3 and 5. Odd numbers which are multiples of the odd number 5 are created by adding for each new value the binary values 0, 0, 1, 1, 0. The next factors, 7, 9, 11, etc., are always written with two additional binary values equal to 0. That is a binary value 0 at the beginning and to the end of the binary previous series. The number of binary values is equal to the value of the factor. Factor 9 is written with 9 binary values. There are always, however, only 2 binary values equal to 1 into the binary series. The second binary value 1 is related to the value of the factor. Within these factors, a structure of numbers appears. An infinity of linear functions defining odd numbers and function of the J parameter appears. Each of these linear functions begins with the multiple value of the factor 3. The first linear function studied is obtained with the odd number ni equal to 3 times 2 times j plus 3. We note that this linear function is written with factor 3 corresponding to the factor of j equals to 0. The other linear functions are written the same way, the sole difference being the increasing value of the factor. The second linear function is written as ni equals to 5 times 2 times j plus 3 and so forth. For each value of j appears an infinity of linear functions defining odd numbers depending on a parameter m. This parameter m brings up the multiple values of the associated factor j. Each of these linear functions begins with the value of the second factor, such as ni equals 3 times 2 times m plus 3 for j equals to 0. We note that this linear function is written with factor 3 corresponding to the factor j equals to 0. The other linear functions are written the same way, the sole difference being the increasing value of the factor. The second linear function is written ni equals 5 times 2 times m plus 3 and so forth. The two types of linear functions form a pair of linear functions. The pairs of linear functions appear for the same factor of j. So, for the factor of 3, the linear function 3 times 2 times j plus 3 and 3 times 2 times m plus 3 share a common point when j equals m equals 0. For factor 5, the linear function 5 times 2 times j plus 3 and 5 times 2 times m plus 3 share a common point when j equals m equals 1 and so forth. This point, common to a pair of linear functions, corresponds to the square of the factor. These points are highlighted in pink in the table. In the table, these pairs of linear functions represent half of an inverted V. These pairs of linear functions are nested within each other endlessly. These pairs of linear functions form a pairs of factors that decompose odd numbers. When the value of an odd number increases, the number of pairs of factors may increase. For example, the value 105 can be decomposed into 3 pairs of odd numbers, 3 and 35, 5 and 21, 7 and 15.